Hello YouTube, welcome to a special edition version of my tutorials. So it's still going to class as a normal tutorial, but firstly, happy holidays to everybody, whether you celebrate Hanukkah or Christmas, whatever, happy holidays. So what we're going to do in this tutorial is add something Christmassy to our game, just something random really. And I'm going to show you what it looks like first and we're going to do it. So if you don't want to do it, you don't have to do it. If you do, you can. Really simple. We're going to learn some new commands today as well. I can't remember. It's mostly to do with animation, but yeah. So you can see, normal character, we're going to be changing lots of stuff soon. But you see in the far end, we get a Christmas tree. And that's it. No, not really. Let's go up to it. You never know, that's not it. So if we go up to it, you will see, as we slowly get towards it, oh, it starts spiking out and flying towards us. So we run away and it stops. So it's not the most perfect, but I like it. So you go up close to it, it'll start spinning and chasing you. The particles are optional, of course. I made them so that it looks like it's actually moving, but if I want to make them fade out instead of just disappearing. But as you can see, the spikes, it actually spins. It doesn't hurt you yet, but it'll follow you anywhere you go, unless you get out of range. Like so. Perfect, right? So let's get on with it. Hello. So, you just saw the demonstration, and if you are still here, thank you for watching. So what we're going to first do is, in the description or on my website, there's a download to download the Evil Tree model. It's not the best model, but it's cool and it works. So to celebrate the holidays, we're going to use a festive Christmas tree. I didn't think Hanukkah candles or anything like that else would suit. But yeah, it's called Evil Tree here, and if we drag it out, it's actually really small. So what we're going to do is click on the Evil Tree, and we're going to go to model, and in the description when you download the model, you'll also get a text file containing this. So it'll just, if I can just increase the font size for anybody who's not in high quality, you'll be able to see it. You get this. So animation, it tells you all the animation, we'll be getting to that later. Size, you've got transform scale, it needs to be 111. So if we just click the Evil Tree, we detect it's 111. That's not one. So that's perfect, so that's the right size. And then the model size here, which I will change to scale factor. So there we go. Will be 0.15, and I've determined it's bigger than the player, but then it's not too big that they'll run away from it, of course. So as you can see, it looks much bigger, but the player actually comes roughly to about here on it. So yeah, it's nice size. So what you want to do next is something we've not looked at, is you want to go to rig here. And what this does, it sets up basically the bone structure or the animation, bone structure for the animation for your object or whatever you've imported. Now for this, since it's not really a character, we don't need a bone structure. So change animation type from humanoid to legacy. And make sure it says store in root. And what this will do is create just a basic animation set, so you import it, it comes with it, and it's going to store it on the actual object. So right here, you can see it stores it right there. So if we were to play it, play everything, we don't want that. So if we go to animations, make sure import animations ticked, click apply, and then come back down. So you can see if we click the play animation, spikes come out, it bends forward, and then that's it. So let's try and break it down. So spikes come out, that's like 0 to 5, we'll do that in a minute. It bends forward because that's what gives the illusion is it coming towards you. Then it's got a gap where it just doesn't anything, and that's called the loop area, so we can just keep looping that bit over and over again and you'd not know. And then it leans back and then closes up. The spike's going really fast because I didn't want it to be slow motion, but yeah. You can edit this if you like, just take it into 3ds Max or whatever. I'll try and import it in as many file types as I can as well, So, if we go to the notepad again, you'll see I've actually listed everything for you. 0 to 5 is spikes out, 6 to 11 is fold forward, 12 to 15 is the loop, 16 to 21 is fold backwards, 22 to 27. But the cool thing is, well, whenever spikes go out, it's always going to fold forward. The spikes aren't going to go out then stop. So what you can actually do is, instead of making this 0 to 5, then 6 to 11, you can just make it 0 to 11, and it'll play all that, then instantly come and play this. So the spikes come out, it leans forward, it comes and gets you. So the first animation I'm going to call spikes out. Here, I'm just going to rename it there, and I'm going to make it 0 to 11. And then I'm going to, it doesn't need to loop, it's just going to do it once. So we click once, we click apply. Okay, you didn't really need to click apply, but hey, I didn't mess up. So the next one is our attack position. So we can copy that, it doesn't matter about spaces. That's 12, which is 1 after this frame here, to 15. So we need the loop, we can put that in. So add 1, make sure you click the plus, so it's got take 1, attack position, and this is the end of that one, so 12. And if you mess up, you can see it glitches, which I really don't like. So we'll do it a bit slowly. 12, 2, and then I believe it was 15. 15. And it does it loop. Make sure you click loop and click. I don't know what add loop frame does, but I ticked it anyway and it sent to work. So just click it and make sure it's called attack position. Capital P, Daniel. No, wait, no. Okay, never mind. Apply. I've done it again. You don't need to keep clicking apply, just keep clicking plus and it'll do it. So the last one, which it didn't decide to save attack position, this one will be spikes in. And it will be 16 to, where is it to? Let's have a look. 27, because you can double this again, so whenever it's going to fall backward, the spikes are going to go in, they're just not going to stay out. So 16 to 27, I'm going to do it. The reason I've left it, so that's to the end, so now you can just click apply. The reason I've left them split up like that is so that you, if you want the spikes out, maybe you want, if you get in a certain range of it, the spikes come out like stay away. Then if you come even too close, it falls forwards and comes and gets you. We're not going to do that, but you can if you like. Don't worry about that error, it's just because we messed up. So now that we've done that, you can see our tree does the exact same, but it breaks it up now. So you've got the loop, and then you got spikes in. So that's how you pretty much break an animation down if you've got one. So let's just clear all our errors because we don't need it. So now this, we're going to click it and actually we're gonna untick play automatically because we just want it to stand there for now. So the next thing I'm going to do is add a nav mesh agent there. And if you haven't watched my nav mesh tutorial, it's my previous two tutorials. Go and watch it, it'll teach you how to do this. But I'm going to basically set this up so the radius we want a bit bigger, like say to there, just so it's got some ground. And I'm going to set the height, when I find it there, to the top of the tree. That'll do. So, oops, we have it set up. I'm going to change the speed to say 15, and the acceleration I'm going to keep to 20, so it quickly gets up to the speed. The stopping distance is how far away it stops, up to you, but don't forget if it's coming at you full speed, it's going to take a while to slow down. So I'm just going to say 5, so it doesn't swallow you, pretty much. Yeah. So the only other thing we've got to do is script it, then we're done. So I'm going to go to scripts, and I'm going to find entities, right there, NPC, and I'm going to just add a new one called Evil Tree. JavaScript Evil Tree. And we can't really apply this to everything, but I'm going to show you a new technique on how to code, well, yeah, code an AI. So, Evil Tree, drag it on, and let's open it up. So let's quickly get through this, it's really easy. First thing we need is range detection. Now we've messed with range detection many times before, and all this is going to be used for is when you're in range of the character, it's going to initiate and start to follow you. That's it. So pretty easy. Private var to create a variable, private variable. We're going to call it range, and it'll be a vector 3 type. And we just gives a good programming, because every time you need to create a variable, it goes, has it been assigned? No, let's spend some extra time assigning it. So if you've got, say, 500 million variables, I know it's a bit much, but think about when you have a full game. If it's assigning every single one, it's going to take a bit more processing power. So it's just always good practice to assign a blank type. So we're just going to go like that. That's it. And then the next thing we need is just to, instead of going GameObject.find all the time, we're just going to put player in here. So private var player, it will be a GameObject equal to null, so it doesn't contain anything. And that's it. So in a start, we can just quickly assign player. So player equals GameObject.find, and we're doing it in the start because then it only does it once, doesn't it? It only runs start once, so you don't need to worry about it going all the time. So now that we've done that, in our function update, we need a way to tell at which stage the object is in. And now in my other AI tutorials, I've done, is it angry, yes or no? Is it paranoid, yes or no? But I find an even better way now. And it's actually the same way I code missions. And the same way Lisp programming, which is known for its AI good properties, does the same. And it's if statements, a lot of them, or case statements, whichever one you want. I'm personally going to use a case statement. So we can go down and we can click private var, because we don't really want to show all these in the inspector, do we? We've got no point. And I'm going to call it stage, and it'll be an integer equal to 0. And then in our function update, I'm going to create a switch statement for stage. If all this is like beyond you, you need to watch my other tutorials because I've done all these already. I'm just basically going over it because, hey, we don't really need to go in depth with it. So if stage here, we'll go case 0, like that. And then every time they move, so like say the player's not in range, it'll do this, or this, or this, or this, or this. Really easy. So, switch here, what's our first one? Let's just get ready. So, find player. So we need to see if the player's in range. So first we need to assign range, don't we? Really simple to do. Apologise for my dog. She always decides to bark at the most awkward times. So we're going to set range equal to player.transform.position, because we want the player's position. And then we're going to take it away from the tree's current position, because we don't need anything else. That's it. And one optional thing you can do is if you want to show what range you are from the tree, you can, but don't forget in game nobody's going to see that, so you don't really need to. So in case 0, we're going to detect if the player's in range, and if they are, we're going to increase stage. So stage is 0, so it'll go loop, 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 loop. Oh wait, look, it's found the player, go to number 1 and loop, 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 loop. Yeah, so it's easy. So we're going to type if range.magnitude is less than, what can we say? I'm going to put less than equals actually, and I'll put 80. So quite a far distance it can come and find you. And all I'm simply going to do is type stage plus plus. That's it. Copy all this, change it to number 1. So, what's our next step? Well, our next step is so the tree's found the player's in range. We want the spikes to come out, we want it to lean forward, don't we? So, we need the animation to play. Now there's one issue with this, we can go into this, is if I were to just type animation.play blah blah blah, it'd work, we know it would, because if we click it, you can see the evil tree, the animation's right there. But there's an issue. When the NavMesh agent tells it to follow something, it sets all the rotation to 0. So it'll look like that while it's chasing us, which is not what we want, is it? Come on, we all can agree. So what a good way to do is if you duplicate your evil tree, and just call the bottom one mesh, M-E-S-H, and drag it inside evil tree. So you've got mesh, you've got evil tree, mesh, stump, tree. Delete the stump and the tree from the evil tree one. So you've got like a parent to it if you wish. Then on the mesh, just delete everything but the animation, the script as well. So you've just got the animation on the mesh one, and on the evil tree, get rid of the animation. And then reset it back to 90. In fact, before you do, take mesh out, I did that yesterday, click the evil tree and set it to 0, like so. So now, you've just got a fully, nicely rotated tree, put mesh back in it, and then it'll work fine. Because mesh now has 90, so it's at the correct position, but evil tree isn't. So if you don't understand what I mean, basically, if you just had mesh as the normal one, whenever it'd start, it'd set it to 0, and it'd chase you while pointing to you exactly like that. If you switch them around, so you've got a parent on top, then it'll chase you like that. Just follow if you don't understand. It's good practice, really. So, now that the animation isn't on the evil tree where the script is, we need to find mesh here. So, how do we find an object? How do we search inside of an object? We use transform.find. So we need to basically go and play spikes out. That's it. Really easy. And I don't think we've played with that much animation, but it's actually really simple. All we're going to type is transform.find mesh, because that's the name of it. Transform.find will find anything inside of the object. So if you've got, say, your character's called mesh, it's not going to find your character, so don't worry about it. So mesh.animation.play, and the name of it is spikes out, like so. And then as soon as it plays it, we just want to skip the next stage. Well, go to the next stage. So it comes down, is the player in range? No, yes, no. Yes. Come instantly down and go, play under animation, continue with case 2. Just like so. So if we were to play it now, I'm not going to because it's getting quite long. It'd basically play the animation, then stop. But it'd only play it once, that's the good thing. So in case 2, we basically need to say, has the mesh finished yet? Yes or no? That's basically it. Has the animation finished? If it has, we need to enable the particles if we've got it, or we need to turn on the nav mesh agent. So the reason we want to turn the nav mesh agent on and off, oh dear, is because while this is going at full speed chasing you, if you get out of its range, it's going to go to your last known position. Now I mean, that's brilliant. That's perfect for a zombie game, or an AI, because that's what they will do. If you got detected by a security guard, he's not going to go, oh, I can't see him no more, I'll just go home. He's going to go to your last position and try to find you. But I don't want the tree to. Personal preference. So what I'm going to do is, on the evil tree, is disable the nav mesh agent. And then I'm going to add the particles to it, and I'm going to do a basic job of it. So I'm going to go game object, create empty, and I'm going to name it particles, and stick it inside our tree, just there. So now that we've got that, I'm going to make sure it's pretty much at the base, so there, and I'll move it down, there, perfect. So I'm going to go to add component, I'm going to type in particle, and I'm going to add ellipsoid particle emitter. I stick with the old ones. If you wanted to turn on the new ones, I can cover it, but it's really up to you. I personally just prefer these, I don't know why. But in particle renderer, I'm going to go element, and I'm going to add a dust, if we have any. Yes, we do, so I'll add some. Well, we don't want fairy dust, we want dust material. There, oops. So I want it to be bigger than the base of it, so it kind of like covers it. So I'm going to set the size grow to 0.1, so it grows in size while it's spawning. As you can see, it's slowly growing. And I'm going to come down to ellipsoid, I'm going to set the X to 1.3 maybe. So as you can see, it's covering it, but I'm going to make it a bit bigger, so 1.5. The Y-axis doesn't need to be that big because it's, well, it doesn't. Move it down a little bit more. And I'm going to set the Z to about 1.7 or 8, so it's longer. And I'm going to make it so it's front-ended, so it's at the front. So it spawns at the front, but as it's moving, it'll be dragging backwards, so it looks like it's going with the air. I'm also, on the particles, I'm going to turn off simulating world space. So that means you can move it like this, and it stays with it. Well, as if you had it on, it'd follow it like that, and I don't want that. So I'm going to turn it off, and I'm going to go to random rotation when I find it. Where is it? Random rotation, I'm going to turn that on, so it randomly rotates in positions. And the max size, I'm going to set to 0.5, and the minimum size 0.5, the max size 2. And as you can see, it's spawning some big dust now. Big dust. I'm going to set the energy to around 1 to 2, so it quickly spawns, despawns, spawns, despawns. As you can see, we're kind of losing it, so I'm going to turn it back up to 2 and maybe 4. There we go, because we want it to stay there and pretty much cover the log so you can't see it. So maybe move it across a little, maybe increase the Y-axis to about 7. There we go, so it pretty much covers it up at the front nicely. So I'm going to go to colour, and I'm going to add some greens for the grass, some dark greens maybe. As you can see, you'll start to go green in some places. Add a little bit of brown, so it's like the dirt is coming up. And maybe a shade of dark green. As you can see, it looks a little bit better. Brown, and then I'll add another brown. So it looks like it's like, when it's running towards you, it looks like it's ripping the grass and the dirt up trying to get to you. And the final leaf on top, which I'm going to do, is I'm going to go to local velocity, not world, local, and I'm going to change, I believe it's the Z to minus 0.1. Okay, we'll try 0.5. There we go. So if you were to click evil tree, you would see that it's kind of zooming behind it. So as it comes towards you, if we move the particles forward a little bit, it'll look like it's running towards you, like so. Of course, I'm not the best particle, I'm not really a graphics designer, I'm more of a programmer, but hey, you could honestly play with this for a long time. So like turn the max emission up to say 99 and 100, so it spawns more of them. Maybe increase the size to like 1 and 2. It's really up to you. You don't even have to animate colour if you don't want, you could just have it smoky. It's totally up to you. I'm going to keep it as smoke this time. I don't know, we'll see if it works, but yeah. So, back to our script. So now that we've got that, we're going to actually turn off particle renderer here. And the reason is because every time we want it on, we just turn it back on, or turn it off. And what it'll do is give us the ability to make it work. So I'm going to go to our script, and in number 2, I'm going to basically see if this animation is still playing. And it's really easy to do. Is we type if, and then in here we find our animation again, so we need transform.mesh animation, that, and then instead of dot play, we put dot, we put the square brackets, I always get confused with this bit, square brackets, name of the animation you want to check. I don't know why it's square brackets, I think it's because you're accessing an array, so spikes out, and then you type dot. Now this is the thing, some people put is playing, so if blah 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 animation dot is playing, but that's what not many people know is that's actually for sound, that's why it never really works. What you need is enabled equals false, like so, and what that'll do is basically say if the animation is playing, because if it's enabled means false, if it's disabled then it's not playing. It's a game object if you think about it. So if it's enabled, it's false. If it is enabled, it's true. Then it won't do everything in here. And what we want it to do in here is firstly transform.find mesh dot, not mesh, apologies, we need particles. Yep, so we want to find the particles, then we want to get the game object, otherwise we get an error. Then dot get component, and we need the particle renderer dot enabled equals true. So we're making it play. That easy. The next step is return on the nav mesh agent. So get component nav mesh agent dot enabled equals true, and then move the stage along. There. So now it'll come down, put it on, nav mesh agent, it will chase us. Easy, right? Let's hope so. So the last thing I'm going to do, because this tutorial is getting really long now, is I'm going to make it actually chase you. And then in the next tutorial, we'll make it so it doesn't chase you. If that makes sense. Yeah. So, in here, what we're firstly going to do is set the spinning motion on the tree. And this isn't actually an animation if you haven't detected. All I actually do is we go in and get the tree here, and we just spin it while the spikes are out. And because the animation's playing, all we're really doing is spinning it. It's that simple, it's really, really easy. So what we're going to do is transform.find mesh / tree, so we find tree, and then on the local Euler axes, angles, we change the z-axis to spin. Really, really, really simple. I don't know why that's 1,000 odd, we'll get rid of that. So, what we're going to do is go back to our script here, and we'll type transform.find mesh, like I said, / tree, and what that'll do is look for an object called mesh, then inside of mesh, it'll find tree. You can't just put transform.find tree because for some strange reason it doesn't find it. I thought it did, but hey. So then we'll put dot game object dot transform dot local Euler, is it Euler or Euler? Angles.z. So the z-axis, and we'll go plus equals. We'll try 15 because I put 10 when I first did it, but make it a bit faster. So we've done that, and the next step is if it's out of range, stop it, right? Kind of. We'll not do that today. We'll do that next time. So we need it to make it follow you. So we'll go get component.navMeshAgent just like we did on the AI. .destination equals player .transform .position. Done. So now if you get in range of it, it's not going to stop until it eats you alive. Ever. Like, ever. It's cool. So, let's go back. There's no sounds on this yet. We will be adding it soon, though. And to finish it, all we're basically going to do is reverse this. So, I'll give you the pseudocode for it. So, case 4 will be if spikes in is false. So, if this is false but spikes in, then all we're going to do is take it back to number 0. That's pretty much it. Really simple. So let's test. So we play it and you can see it's there. We run up to it and it should spikes out and start chasing us and enable the particles. So as you can see we've got a null reference exception, which is good. So line 26 we have an error, and simple error, there's no, it's lowercase o, silly me, and lowercase o again. Basic thing, but yeah, so that will fix it now. Basically it was saying it can't find the animation. It's like, what animation? Now we've gave it the animation, it should play. Run up, it will find us and spin. Oh no, it's chasing us, look at that. I definitely think it went better with green and brown particles. But as you can see it's wobbling a bit. I might change the speed back to 10. But as you can see it won't ever stop. Like, ever. All the way across the other side of the map, and you see it will still chase us. Yeah, we will fix that next time. But yeah, so what we can do eventually is put a tutorial section, so like this tree here, and like when it starts to spin we like take a screenshot. It brings up the death tree, blah blah blah, weakness, fire, because obviously it's a tree. But yeah, so I'll change this back to 10 because it looks nice as a 10. So you saw it spike out and come out. If you want to speed up that animation or slow it down, edit the default file and you should be able to. So I'm going to go and play on, actually I have no idea, I may play Fallout or something, but yeah. So now it chases us nicely. What we can eventually do in the future is like, so it's showing you like and something. But plans for future tutorials, which I think you should probably know, we're going to be changing the characters once again from these bad ones to some make human animations, because they're really cool. Well, animations models. I'm also going to be making the camera so it works a lot better, and then we're going to sit and non-stop bug fix everything, because our game is terrible at the moment, let's face it. Oh look, it's still chasing us. Hello, I'm here. Oh, there we are. But yeah, thanks for watching. Everybody gets virtual cookies for watching this far. Here's a trick question for you all. If you did watch this far and you are listening to this message now, 1, you are indeed awesome for watching my entire video. I mean it. I really like it when people do that. It shows that I actually do good stuff and they don't like get bored. 2, please just comment below saying the word mini roll. Just mini roll, and then I'll know you've watched it to the end. I don't know why it's mini roll. I've got a cake bar in front of me that says mini roll on it. Mini roll. See you later.